Hello everyone, I am doing fine. I'm so glad to be here today to present about the electrical machine. First of all, our group members have Deng Baoyun, Wang Jixuan, Lo Mengyao, and me. Next, I will show you all the content of the topic today. The first content is about the research and summarize key standards, and the second one is about identify legal compliance requirements. Next is the application of standards, and the last one is reflection about the electrical machine. So let's move on the first content, research and summarize key standards. In this topic, I will show you a few several types of international and national standard for electrical machine safety. The first one is IEEE, Institute of Electrical and Electronic Engineers. And next is IEC, International Electron Technical Commission 60034 series. And the third is OSA, Occupational Safety and Health Administration. And the fourth is NEC, National Electrical Code. So I will explain the IEE standard first. So the first one, IEEC 37.69 standard, is about guide for AC motor production. These standards provide guidelines on production method for AC motor, including overcurrent, phase failure, overload, and other fault conditions. The relevance to electrical machine operation is protect motor from damage due to electrical fault and operation failure, ensuring reliability and safety in industrial applications. Next, the IEEE 841 standard is for civil duty motor. It has specific requirements for general purpose motor used in severe operating environments, focusing on robustness, durability, and reliability. Besides that, it is important for industry that require motor to withstand extreme conditions, ensuring longevity and safety of electrical machinery in harsh environments. Next is IEC 60034 series. This standard is applicable to all rotating electrical machines except rotating electrical machines for rail and road vehicles, which are covered by the IEC 600349 series for standards. Next, the IEC 60034-1 standard is about the rating and performances. It establishes the general requirement for the rating and performances of rotating electrical machines. This standard ensures consistency in how machines are rated and performed, which is fundamental for proper machine selection and operations across different applications and environments. The second standard for IEC 60034 series is IEC 60034-2, which is method for determining losses and efficiency. This standard is for measuring and calculating the efficiency and power losses of rotating machines. The relevance of the operations with efficiency is a critical factor of energy saving and operational costs, making this standard essential for industry focused on sustainability and energy efficiency. Next is OSA standards. OSA Electrical Standards 29 CFR 1910 Subpart X is related to electrical safety in workplaces. The standard focuses on general electrical safety, addressing topics like wiring, equipment standards, and safe work practices to minimize the electrical hazards. Besides that, these regulations help ensure that electrical machines in workplace operate safely, providing protection against electrocutions, fires, and explosions. So next, the OSA 1910.303 standard is about the general requirements for electrical systems. This standard provides general requirements of electrical equipment installations covering standards for circuit protections, disconnecting means and proper enclosure. Furthermore, these requirements help prevent electrical accidents by ensuring machines are properly protected and safely operated. Next, the OSA 1910.305 standard is about wiring methods, components, and equipment for general use. This standard addressing safe installations practice wiring and grounding for electrical machinery and components. Besides that, it also ensures that electrical machines are properly installed, which is crucial for both worker safety and machine integrity. Next, NEC National Electrical Code (NFPA 70) is related to DC and AC machine installations. So for the NEC Article 430 standards is about the motors, motor circuit and controller. For the purpose, it has specific requirements for motor installations covering aspects like overload productions, grounding and disconnecting means for motor circuit. And it's also crucial for safely installing and operating both AC and DC motor, helping to prevent overload and short circuit, which could lead to electrical fire or equipment damage. Next is NEC Article 445 is standard is about generators. The purpose is about cover installations requirement for generator, including wiring, protections, and grounding guidelines. Besides that, this standard also important for safe operation of generator, particularly in scenario where power continuity and safe installations are critical. So this is all about the international and national standards for electrical machines. Thank you.
Hello everyone, my name is Meng Yao and I am a student from 2B LR Group 1 Section 1. Today I would like to explain about the identified legal compliance requirement. Legal compliance requirement can be divided into two parts, which is legal compliance requirement and also specific safety requirements for machine. First of all, I would like to explain about the legal compliance for electrical machine. As you guys see in this table, legal compliance can be divided into five, which is OSHA standard, NEC compliance, EPA regulation, NEMA standard, and also certificate requirement. Occupational Safety and Health Administration, OSHA, is a guidelines for worker safety around electrical machine. The next is NEC compliance, which is also named by National Electrical Code. It's the most complete source for codes covering grounding, wiring methods, and insulation to de-risk hazard in most states. The next is Environmental Protection Agency (EPA) regulation. The EPA is in charge of the electrical machinery eco-friendly record with a special focus on the place where pollutants may be an issue. It is also comprises appropriate disposal of machining parts, especially if they contain dangerous materials and emission limitation to pollutants. National Electrical Manufacturer Association (NEMA). NEMA regulates electrical equipment standards that will make them be operated in a safe and efficient way. NEMA standards are non-binding; nonetheless, they have been widely adopted and frequently cited by OSHA, NEC, and other regulatory bodies. And lastly is the certificate requirements. Certificate is a slogan that most electrical equipment, especially in commercial and industrial environments, must have to be safe and secure. This is usually done by credible bodies such as Underwriter Laboratories (UL) to make sure all security standards are met. Next, I would like to explain about the safety requirements for electrical machine. From this table, we can know that a safety requirement can be divided into four, which is lockout or take-out procedure, grounding requirements, installation standard, and also enclosure and guarding. For lockout or take-out procedure are important to ensure safety during maintenance or repair. This means disconnecting the machine from its power source, locking the switch or breaker, and then taking it so it is known by people that reactivation until it's safe is prohibited. Next, for grounding requirements, use a proper grounding is highly recommended to avoid electrical shock or fires. The NEC has extensive guidelines for the grounding of machine that operates with both AC and DC. AC machines must have a neutral conductor grounded to limit shock hazard, and DC machines are grounded either through their frames or at grounding conductor. While for insulation standard, from the operator perspective, the machine will not get damaged as it is properly insulated. Assembling insulation materials with the right properties corresponding to the applicable voltage and environmental condition, which is temperature and humidity, should be a priority. For AC motors. Such installation must comply with IEE 43, while DC machines commonly follow IEEE 95 standards. Lastly is the enclosure and guarding requirements. Electrical machines have to be enclosed and guarded to secure operators from the above stated mechanical, electrical, and spark hazard. According to our SHA and the NEC, guards for machines with a size, voltage, and environment that have different requirements. That's all from me. Thank you.
Hello everyone, this is Sean here. Now we go to the application of standard. Now, firstly, we have a sample of hypothetical scenario, which is installing a new AC motor in a water treatment plant. Here is the picture of the water treatment plant. Let's see. An electrical engineer is hired to oversee the installation of a 150 kilowatt three-phase AC motor at a water treatment plant. The motor will drive a high-capacity pump critical for water circulation. The engineer must ensure the installation complies with all relevant safety and legal standards to protect workers, equipment, and the environment while adhering to local regulation. This means that the electrical engineer need to follow up the standard that set by the government or global. Like the slide before this, which is example for the IEC and so on. Now we go through the challenge and consideration that may face by the electrical engineer. The firstly is environment factors, which is the plant is located in a humid environment with potential exposure to water splash and corrosive chemicals. This means that the engineer needs to make a plan or draw a blueprint before he start the construction to build the water treatment plant. Hence, he need to solve these environmental factors before he start to build it. Next, electrical safety risk. High voltage, which is 480 volt, and current levels require carefully grounding, insulation, and fault protection. This means that before he need to test the construction of water treatment plant, he need to make sure that the high voltage and current level is grounding, insulation, and fault protection to prevent any safety issue. C. Compliance requirements. The installation must meet local electrical code, workplace safety standard, example OSHA, and relevant motor specific standard, example IEC 60034 or NEMA MG1. This means that different place have different standard. If he want to start his installation, he must to follow up the local electrical code or standard to prevent the safety issue to the local construction. Now we go to the step to ensure compliance with standard and regulation. Firstly is pre-installation planning. Understand applicable standard, which means that follow up the local safety code, temperature regulation, IE standard, or national electrical code, NEC. Next, review manufacturer specification. It obtain and study the motors, datasheet, installation manual, and safety requirements. Means that different method or different construction have different specification, and the engineer need to obtain the motors datasheet. Next is a risk assessment, which is conduct a hazard analysis to identify risk. Example, electrical short, overheating, mechanical failure, or short circuit. Next is site assessment. It inspects the installation area to ensure adequate ventilation, grounding, and structural integrity. Secondly, design and preparation. First, prepare electrical schematic like design wiring diagram, including breakers, fuse, and voltage relays, ensuring compliance with NEC or similar codes. This can help the engineer to have a easier wiring, thus grounding and earthing plan. Design an appropriate grounding system as per standard like IEE 50. It can avoid lot of safety issues like electrical shock. Next, select compatible components. Ensure all components meet the motor's voltage, current, and insulation requirements. So that the cables or switchgear is need to comfortable to the wiring. Thus, submit plans for approval. By submit design and plans to local authorities or regulator bodies for approval if required, to make sure that the standard is fixed to the local code. Thirdly is go through the installation. Now clarify procedure. It ensures the installation is carried out by certified electricians and supervised by the engineer. Not everybody can install or construct the wiring easily. It needs to be certified and or supervised by the certified engineer. Next, follow manufacturer's guidelines. Adhere strictly to the motor manufacturer's installation procedures. Verify electrical connection. Engineer need to check connection for priority, proper installation, and tightness to provide a safety condition. Next, implement safety measure. Install safety device such as emergency stop button, interlocks, and protective covers to prevent an emergency situation happen. Last, labeling and documentation. Clearly label circuit breaker and the motor with voltage, current, and safety information to give a easy way to the other engineer or technician to check or maintenance. Fourth, inspection and testing. Initial testing. Perform electrical tests such as insulation, resistance testing, continuity check for grounding system, no load and load testing of the motor. It can prevent some short circuit for the wiring. Next, safety checks. Verify compliance with safety centers. Confirm emergency stop functionally. Test overcurrent and overvoltage protection device. Next, third-party inspection. Engage a certified inspector to review the installation for compliance. You need a third-party certified inspector to check or review all the installation of the wiring is in safety and in complete. Fifth, compliance documentation. Prepare reports, document all testing, inspection and compliance checklists to easier maintenance after that. Next, obtain certification. Seek necessary approval or certificate from regular bodies. The certificate can show that the wiring or installation circuit is have checked by or reviewed by the certified inspector. Lastly, operating and maintenance. Preventive maintenance plan. Schedule regular inspection and maintenance as per standard and manufacturer guidelines. This need to check to the guideline, global guideline to prevent installation or a circuit is overused. Lastly, audit and update. Periodically audit the system to ensure ongoing compliance with update standard and regulation. That's all from me. Thank you.
Hello everyone, my name is Ding Baoyun and today I will be discussing about importance of adherence to safety standards and legal requirements. As you can see, there are three main reasons why we should respect to the safety standards. Ensuring human safety is the first reason that we should adherence to those safety standards. Standards IEEE 11584 provides a method to calculate arc flash hazard in industrial and commercial power systems to help engineers determine safe working distances. Secondly, the act of obeying to those safety standards is to protect electrical machines and equipments. For instance, the standard IEC 60364 deals with electrical installations of buildings providing safety guidelines for wiring, grounding, and protection against equipment failure and installation breakdown. Thirdly, adherence to the safety standards give environment protections. As OSHA standard includes requirements for safe practice such as lookout or takeout to reduce the risk of electric fires that may release toxic chemical or pollution. Next, I would like to explain why adherence to legal requirements is critical in the field of electrical engineering. The first reason of adherence to the legal requirements is legal and financial accountability. This is because the company that adhere to legal requirements get assured organizations involved in electrical engineering are held to a high standard of care. Machines often need certification like UL certification to verify adherence to safety standards, whereas the company's failure to meet legal requirements might lead to serious consequences like fines, lawsuits, and criminal charges. Secondly, with respect to the legal requirement for preventing potential electrical hazard and accidents. As regular maintenance of electrical installations and equipment to identify and address potential issues before they become hazard. For example, the OSHA standard includes using PPE, adhering to lookout and takeout, and ensuring electrical isolation during maintenance. Last but not least, we must adhere to the legal requirement in order to establish professional standards. Some of the organizations provide guidance for engineers on best practices and ethical responsibilities. These actions has ensured that work across the industry adhere to consistent and has public trust in electrical engineering profession. For additional information, CSP stands for Certified Electrical Safety Compliance Professional, which provided by NEPA, demonstrates an individual has the knowledge and skills necessary to implement and maintain electrical safety program in the workplace. Next, potential risk of non-compliance in electrical machine operation may lead to occur electric fire, electric shocks, and arc flashes. For those accidents might cause injury, equipment damage, and legal liabilities. So from these assignments, it reflects that the safety standards and legal requirements are essential in the field of electrical engineering. By adhering to these standards, it has ensured safe and compliant prevent equipment damage. So remember, safety in the electrical industry is not just about following rules, it's about creating a culture of safety where every precaution is taken to prevent any incidents and injuries happens. Thank you.